Hey guys, let's talk about wheel and axle. So a wheel and axle system, or a simple machine, consists of two parts. You have the wheel, which is exactly what it sounds like, sort of a circular object that you turn, and then axle, which is a rod that spins as well as you turn the wheel. However, what happens a lot of times, it's also the axle might drive the wheel itself. So you can have two situations. You can apply the input force or the effort force at the wheel. And in this case, the wheel drives the axle. Or when the effort force is applied at the axle, then the axle is driving the wheel. Okay? So the axle might be an input and the wheel the output, or vice versa. Some examples of this are a steering wheel. In the steering wheel, you turn the big wheel and you drive the axle, right? That then drives the shafts. So that's wheel driving the axle. But in a car as well, you have the actual tires, the wheels, right? That are driven by the axles that are connected via different systems to the engine. So in that case, right, in the case of car tires, the wheels are driven by the axles. Right? So those are the two situations. And then, of course, the mechanical advantage will differ. Right? You'll have a mechanical advantage greater than one when wheel is driving the axle. So wheel driving, mechanical advantage is greater than one, and axle driving, mechanical advantage is less than one. Okay, so let's look at actual mechanical advantage and ideal mechanical advantage. With actual mechanical advantage, it's the same as with every simple machine. So basically, you take your force of resistance and divide by force of the effort. That might be torque because it's rotational motion, but essentially, however much force is applied at either one, right? So you just divide the resistance force by the effort force, and you can calculate actual mechanical advantage of a wheel and axle. With ideal mechanical advantage, the difference is, if you take distance of effort divided by distance of resistance, you have to consider what the distance of the effort and resistance are. And those are actually circumferences of the wheel and axle. So let's make this example wheel driving the axle. So wheel drives axle right here. So the first example, wheel driving the axle. So you got distance of the effort. So that's the circumference of the wheel, right? So you do 2 pi r wheel divided by distance of resistance being the axle here. So that's 2 pi r of the axle, right? So you can probably see right away that you can cancel out 2 pi. So you're left with radius of the wheel divided by radius of the axle. However, oftentimes, more often than not, engineers will use the diameter because it's just easier to measure across the wheel or the axle, right? When you're trying to get their size, right? So you'll just have diameter of the wheel, in this case, divided by diameter of the axle. Now, of course, if the axle is doing the driving and the wheel is the output, then the difference will be, in the second situation where you have axle driving, right? Axle drives wheel. What you're going to see there is that ideal mechanical advantage is calculated by taking the diameter of the axle and dividing that by the diameter of the wheel. So that's basically how you calculate wheel and axle.